Hello everyone, I am from Isabella Thoburn College and my topic for the project is rank nullity theorem. So I will firstly explain some basics. So before moving on the topic rank nullity theorem, I would like to explain null space. If V and W are two vector space over same field F and T is linear transformation. So briefly, linear transformation is a property such that T of C alpha plus beta is equals to C T alpha plus T beta. So T is LT from set V to W. We can also write like this: T is a linear transformation from V to W. Then null space of T is denoted by NT और दिस, मतलब हम लोग ऐसे भी डिनोट कर सकते हैं और ऐसे भी. एंड गिवन एज एन टी इज इक्वल्स टू इन ब्रैकेट अल्फा बिलोंगिंग्स टू वी एंड टी ऑफ अल्फा इज इक्वल्स टू 0. मतलब एन टी में वो एलिमेंट्स आएंगे जिनकी इमेज 0 होगी. नाउ नलिटी ऑफ एल टी. If T is linear transformation from set V to set W, then number of elements in basis of null space of T is known as nullity of T. Nullity of T is equals to dimension of NT. Now range space. If V and W are two vector space over same field F and T is linear transformation from set V to W, then range space of T is denoted and given by RT is equals to in bracket beta belongs to W. Beta is equals to T alpha where alpha belongs to V. Here difference between nullity of T and range space is the element in nullity of T belongs to V and element of range space belongs to W, as here it is written beta belongs to W. Here's one theorem of range space. If T is LT from vector space V to W, then show that range space of T is subspace of V. Given that T is LT from vector space, it is given, and then we have to show that range space RT in which beta belongs to W, beta is equals to T alpha where alpha it is also subspace of W. So basically we have to show that range space is a subspace of W. So we know that for showing subspace we have to prove two conditions. First is the set is non-empty and another one is C alpha plus beta also belongs to that very same set. So first property to show that RT is non-empty. W is a vector space. So 0 must present in W. As V is vector space, so 0 belong to V. And 0 is equals to T of 0. So 0 also 0. Here's element. And T alpha is the image of, as we can see in range space, T alpha is image which belongs in W. So T alpha, T of 0 is also present in V. RT, I'm so sorry, T of 0 is also belongs to RT, then 0 is also belong to RT. Hence RT is non-empty. To show that for every beta 1 plus, beta 2 and C belongs to field, we have to show that C beta plus 1 plus beta 2 belongs to RT. So basically we always prove C alpha plus beta. Here in place of alpha and beta I am taking beta 1 and beta 2. Let beta 1 and beta 2 belongs to RT and C belongs to field, which implies that beta 1 beta 2 belongs to W. Then there always exists alpha 1 and alpha 2 belongs to V such that beta 1 is equals to linear transformation of alpha 1, as I have explained in range space. So beta 1 is equals to T alpha 1 and beta 2 is equals to T alpha 2. Mark this equation as equation number 1. Now as we know that beta 1 and beta 2 belongs to W and C belongs to F, so C beta plus beta 2 belongs to W, as W is vector space. We know that W is already a vector space. Now C beta plus beta 2, we are putting values of beta 1 and beta 2. So we get C T alpha 1 plus T alpha 2. Now we can write C T alpha 1 T C alpha plus 1 from the property of varied linear transformation. So C beta plus 1 plus beta 2 is basically written as T of C alpha 1 plus alpha 2. Mark this equation as equation number 2. Alpha 1 and alpha 2 belongs to vector space V and C belongs to F. So C alpha 1 plus alpha 2 belongs to V. So we can write this as T of C alpha 1 plus alpha 2 from the property of linear space. Linear transformation which belongs to RT. So C beta 1 plus beta 2 belongs to RT from equation 2. Hence RT is subspace. Now the next topic for rank nullity theorem is rank of T. If V and W are two vector space over same field F and T is linear transformation from V to W, then rank of T is total number of element in basis of range space of T. As I have explained, range space. So basically rank of T is equals to number of elements in that very set. Means suppose in this set we have 10 elements. So what is the in range space we have 10 elements. So what is the rank of T? The rank of T is 10. The same is written here. Rank of T is equals to number of element in basis of range space. Now our topic and the most important topic, rank nullity theorem. If V and W are two vector space over same field F and T is linear transformation from set V to W and V is also finite dimensional, then we have to prove that rank of T plus nullity of T is equals to dimension of that very set V. So now proof. We have given that T is a linear transformation from V to W and V is finite dimensional. And so NT is also finite dimensional because NT क्या है? NT हमारा सब स्पेस V का है. अभी हम लोगों ने यही थ्योरम में प्रूव करा है लास्ट थ्योरम में. लेट डायमेंशन ऑफ V इज इक्वल्स टू 10. ये हमारा सपोजिशन है कि हम लोग डायमेंशन ऑफ V को n लेट करेंगे एंड डायमेंशन ऑफ NT को m लेट करेंगे. Now we have to show that rank of T is equals to n minus m, as here we are taking rank nullity of T is equals to m and dimension of V is equals to n. So rank of T from here n minus m. Since dimension of null space is m, so we can write like this, dimension of NT is equals to m. Let, अब हम लोग let करेंगे एक set B1. Set B1 in which alpha 1, alpha 2, alpha 3 and so on alpha m, मतलब यहाँ पे m एलिमेंट्स है तो लास्ट एलिमेंट हमारा क्या है? अल्फा m is the basis of NT. As B1 is Li subset of NT, so B is also Li subset of V because NT is subset of V. So B1 is also part of basis of V. अब हम लोग क्या लेट करेंगे? हम लोगों ने प्रूफ कर दिया, हम लोग लेट करेंगे B2. B2 हमारा क्या है? B2 हम लोगों ने माना है हम लोग का V का हम लोग का है. तो B2 इज इक्वल्स टू अल्फा 1, अल्फा 2, अल्फा 3 एंड B2 में हमारे n एलिमेंट्स हैं और जो B2 है वो हमारा सेट V की हमारी बेसिस है. तो इसके टोटल एलिमेंट्स n होंगे बट इसमें हमारे जो नलिटी T थे उसके भी एलिमेंट्स होंगे. तो अल्फा 1, अल्फा 2, अल्फा 3, अल्फा m plus 1, m plus 2, so on alpha n is basis of V. Since B2 belongs to V, so alpha 1, alpha 2, alpha 3 dot so on alpha n belongs to V. Now image of मतलब जैसे here it is beta 1, it is beta 2, it is beta 3 as I have explained in range space. So T alpha 1, T alpha 2, T alpha 3, T alpha m, T alpha m plus 1, so on, T alpha n also belongs to range space. Let us consider a set B. So basically what is B? B is our RT. B is our rank of T. In rank of T, we have to prove that there are n minus m elements. To subtract n minus l elements from above equation, we get T of alpha m plus 1, T of alpha m plus 2, T of alpha m plus 3, so on, T of alpha m n. Now we have to show that this very set is basis of RT. So for proving basis, we have to show two conditions. First is we have to show B spanned RT, and second one is we have to show B is a linear Li, linearly independent. So first condition, let B belongs to RT. So then there always exists alpha belongs to V such that beta is equals to T alpha. Since alpha belongs to B, so there exists C1, C2, here all C1 to Cn are constant belonging to field. All the elements of field are very constant such that alpha is equals to C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 plus so on Cn alpha n. Here B is equals to T alpha. So beta is equals to transformation of इस पूरे के हम लोग यहाँ पे image T of C1 alpha 1 C2 alpha 2 so on Cn alpha n. As we know that T alpha 1 T alpha 2 are the elements of null set, null space. So image of T alpha 1 T alpha 2 T alpha m to T alpha n are 0. So here we get Cm plus 1 T alpha 1, there all are 0. We get Cm plus 1 T alpha m plus 1, Cn plus 2 T alpha m plus 2, Cn T alpha n, which I have written here. So we have proved that B spanned RT. Now we have to show that B is linearly independent. Let Cm plus 1, Cm plus 2, Cm plus 3, so on Cn belongs to field such that Cm plus 1 T alpha m plus 1, Cm plus 2 T alpha m plus 2, it is linear combination which is equals to 0. For Li it should be equal to 0. So this all is equals to 0. As we know that Cm plus 1 alpha m plus 1, Cm plus 2 alpha m plus 2, so on Cn alpha n belongs to null space, and A1, A2, A3 all belongs to field such that this is equal because B1 is basis of null space. So in field minus A1 minus A2 also belong. Here we get minus A1 is equals to minus A2 which is equals to minus AM, so on is equals to Cn, as B2 is basis of V. Now Cm plus 1 is equals to Cm plus 2, so on Cn equal to 0. Hence here B is Li, since यहाँ हम लोगों ने प्रूव कर दिया कि बी एल आई, क्योंकि जितने भी कांस्टेंट हैं वो किसके इक्वल है, 0 के, विच इज़ द कंडीशन ऑफ लीनियरली इंडिपेंडेंट. So B is Li and spanned RT. So we have proved that B is basis of RT. Hence dimension of RT is equals to number of elements in B, and number of elements in B is n minus m. We have considered before. Rank T is equals to dimension of n is dimension of V and m is dimension of means nt. So here we have proved rank nullity theorem, which states that rank of T plus nullity of T is equals to dimension of V. Thank you.